Assalamu alaikum. So we are in example 1 of module 9, which is speaking about ADC in our course Microcontrolling Start as Professional. I included some quick review about what we study in video 1. You can refer to it before starting the example. So all the details are here for quick revision for them. Now let me move here and speak about how to initialize the ADC. Usually we do a function for initialization. So in ADMax we put refs0 to 1. So this is to make the internal reference. We enable the ADC and we choose the prescaler. So in this case we choose the prescaler 111, so it's 128. This is the function that we explained previously in when we speak about the ADC in the first video. So I just go through it very quickly. So it's the output is 16-bit because it's actually 10-bit, but we need 2 registers, so it's 16-bit. The input is 8-bit, which is the channel. Here we just make some operation. This one is to make sure that all the other bits is 0 and we keep this as they are. This one is just to clear the 3 bits. So it's all one except 0, 0, 0. So make sure that the first 3 bit, which is responsible for choosing the channel, is 0 before we OR them with the channel. The channel is passed to this function. So if you want to use any channel, you pass it to this function. Here we start the conversion. So by writing 1 to ADSC, we start the conversion. Here we make a loop waiting for the conversion to finish. When the conversion finish, we return the ADCW. So the function will return this value, which is actually the variable contains the ADC conversion value. So let's start now the example 1. So suppose we have a temperature sensor connected to channel 7. So channel 7 will be passed to this function. So here we pass 7. 7 is 111. So here 111 will be ORed with ADMax. So this will choose channel 7 as input. So connected to channel 7 of the ADC in the microcontroller at mega 32. The temperature sensor output is 1 millivolt per 0.1 degree Celsius. So every change of 0.1 degree Celsius will cause increase in output of the temperature sensor 1 millivolt. So the output is range between 0 to 5 volt. So that means we can use the internal reference. Pin BC0 is connected to a relay to control a heater. Pin BC1 is connected to a relay to control a fan, and pin BC2 is connected to a relay to control an air conditioner. So we are using port C as output to control 3 devices: heater, fan, and air conditioner, AC. The heater is switched on if the temperature is less than 10 degrees Celsius. The fan is switched on if the temperature is greater than 20 and less or equal to 30 degrees Celsius. If the temperature is above 30, we need to run the AC, the air conditioner. Otherwise, all devices are switched off. So we will construct a code to read the temperature from channel 7. So we will connect temperature sensor to channel 7, and we need to write the code to convert the voltage that will come from the temperature sensor to degree Celsius. We are not going to use relay, we will just use LEDs for our sensors, just to show the output. So let's see how to run the program. Of course, the header files. So this function, we just use it as it is. So this function is to read the ADC. The output of this function can be integer or can be unit 16-bit. So the output is passed to a variable. So this is the initialization. So we are using the internal reference and to enable the ADC, and we use the 128 prescaler. Okay, the important part is here some variables. One variable is to read the millivolt. This is the ADC result. We want to change it to millivolt and then to degree Celsius. So this is our main program. It's continuously run. So ADC result, this variable is taking the value of channel 7. So we pass channel 7 to the function ADC read. So this is the function. We pass to it channel 7. So the output will be the ADC conversion value. So this value is the 10-bit output. We need to convert it to millivolts, so we use the equation ADC result divided by 1024 multiplied by 5000 millivolt, because the range is between 0 and 5 volt or 5000 millivolts. So this will get the voltage. Now we need to change the voltage to Celsius. So we said here every 0.1 degrees Celsius equivalent to 1 millivolt. So to get the Celsius, we need to divide the value in millivolt by 10. So we divide here the value by 10 and we get the degree Celsius. Now we have the value. We need to build our conditions. First of all, we make board C as output. We follow the ranges that is given in the question. So if the Celsius, the degree is less than 10, we give 1 to board C0, which is connected to the heater. If it's between 20 and 30, we give 1 to board C1. And if it's above 30, we give 1 to board C, which is connected to the air condition. Otherwise, board C is 0. That means nothing is running. And that's all for our program. So this program will loop continuously. It will always read the value from channel 7, change the value of ADC to millivolt, then change the millivolt to Celsius, and then compare the value and act according to the value of the temperature. Let's move to the circuit and see how it is working. This is the circuit of example 1 module 9. So as you see, we have the temperature sensor. It's like simulated using this device. The input is connected to channel 7, and this is VCC and ground. The output we simulated using the 3 LED. So this to simulate the heater, this is the fan, and this the air conditioner. We go to AVR Studio, write our program and build it. Then we upload the program to our circuit. Then we run the simulator. So as you see, the temperature here is 57, so the air con should be on. Now we decrease when it is less than 30. So you see now 31, 30, less than 30. The air con is switched off and the fan is on. We reduce again. So if it's less than 20, nothing on because it's greater than 10. Now if it's less than 10, the heater will be on. So according to the temperature, the output will control the devices. Now I show you the implementation using the hardware. So as you see, I'm using this sensor, LM35 temperature sensor. It has 3 pins, 2 pins connected to VCC and ground. So I use the VCC and ground from the training board, and the middle one is connected to pin ADC 7 because I'm going to use channel 7. The LED, the 7 LEDs, I connect them all to board C pins. So all board C pins are connected to the 8 LEDs from L0 to L7. Now I connect the programmer to the PC. Okay, and switch on the power supply. The programmer is okay, green, so we can go and upload my program, which is already built. So I upload, apply, read, memories, we go to the place where I store my program, the HEX file and program. So now, as you see, the temperature in the room is around 25. LED 2 is on. Now I try to increase the temperature, so I will use lighter. Please be careful. Okay, now you see the LED 3 is on. Okay, when temperatures go down, LED 2 is on. Of course, LED 1 will not open because the temperature of the room is in 20 something, it's not less than 10. Okay, only in simulator we can make it less than 10. Thank you for watching and see you in next video.